This is question number 9 of homework 6 for chapter 6. The table below shows current and expected future 1-year interest rates, as well as current interest rates on multi-year bonds. Use the table to calculate the liquidity premium for each multi-year bond. So here you're provided with a table with the number of years, year number. And you have a 1-year bond rate. So the meaning of that is you can check by solution to the question number 8. This is actually a let me just pull out that this is basically what that means. You have a a series of 1-year interest rate. So you here actually have 5 years. So for the first year, the interest rate is 2%. So this is 2%. And then second year, 1-year bond, it's 3%. And third year, 4%. Fourth year, 7%. And finally, fifth year is 9%. 9%. So like what I said in the solution to question number 8, because starting from here, the year number 1, because here my year actually starts from 0, so that means the second year actually starts from the number 1 here. Starting from year number 1 for the second year, all these interest rates, all these 4 interest rates here are expected. They are not necessarily actual interest rates. So that means when you actually get to this end of the first year, these interest rates might change. But when you stand here, current time spot, you expect that after 1 year, you're going to earn 3% on a 1-year bond. You expect that after 2 years, you're going to earn 4% on another 1-year bond. And you expect that after 3 years, you're going to earn 7% for a 1-year bond, and so on and so forth. So that's what these numbers here mean. A multi-year bond rate. So this has a different meaning, multi-year bond rate. Why don't I erase that? Okay, so let me just continue to add. So this is a so investors have 2 choices. They can invest in this, suppose this is five series of 1-year bond. So that's their option 1, option A, and it's called option A, okay? But alternatively, they can also choose option B. Option A, they can earn 2% for the first 1-year bond, and they expect they can earn 3% for the second 1-year bond, and they expect they can earn 4% for the third 1-year bond, so on and so forth. And so that's their first choice, option A. And the second choice, option B, is instead of that, they have to reinvest basically their money in 5 different 1-year bonds. They can also choose to invest in just one 5-year. Five-year bond. This is a long-term bond, right? They can just invest in just a one 5-year bond. 5-year bond. So that's their second choice. And if they choose option B, their interest rate will be I5. I subscript 5 here stands for the number of the maturity. And we have a second subscript, which is 0. That, like what explained in the solution to question number 8, stands for the time spot we stand. So I always assume we stand at time 0, but you can also stand at time 1. Then here, actually, you only have 4 years left. So 50, that's what they stand. That this means that's the annual interest rate for the 5-year bond. So every year, you choose a long-term bond, 5-year bond, but every year you expect that it's not expect, actually, every year you know that you're gonna earn this. So that's basically determined by the contract, by the interest rate. When you buy the bonds, it's not contract, it's based on the price when you bought the bond and the future payment schedule, like the coupon payment, and by maturity you're going to get your face value back. So that based on those information, and every year you expect this return I50. So that's your second choice. And this, when we go back to this question says please use the liquidity premium. So obviously this is based on the liquidity premium theory. So in this chapter we talk about 3 theories that can potentially explain the term structure of interest rate or yield curve. So we have the expectation theory, we have the segmented market theory, but these 2 theories, even though they can explain a part of the what we call the stylized facts about the term structure, but they couldn't explain all of them. So combining these 2, the expectation theory and the segmented market theory, then we arrive at this so-called liquidity premium theory. So what this liquidity premium means is that now investors, they have a preference, even though this I50, on average, this I50 is the same every year. The long-term bonds earn the same interest rate as the short-term bonds, but investors actually they will prefer the short-term bonds. Why? Because short-term bonds, they have short-term, so their interest rate risk might be smaller, right? They don't have to invest in the bonds for such a long time, so they prefer this short-term bonds. So in order for the investors to be willing to buy and invest in the long-term bonds, then the only option is actually to increase this interest rate offered by the long-term bonds. So you cannot simply make the long-term bonds to be the average of the short-term bonds, but you have to add some premium. So that's called the liquidity premium. And then if you go back to my lecture slides, so you see this is expectation theory. Expectation theory means INT. That's basically that I50 there. So I should put this as 50. Then that's gonna be this will also have to change. This will be the average of this 5-year, 2%, 3%, 4%, 7%, 9%. That's 5 years, 5 interest rates for a 1-year bond. So that's what this expectation theory means. So INT equals the average of this a series of future 1-year bonds interest rates. But liquidity premium theory, they are based on the expectation theory, but they add one more component. So without this second term, it's basically expectation theory. But then, because as we said, in order for investors to be willing to buy and hold the long-term bonds, you have to add this so-called liquidity premium. So that means the long-term bond on average, their interest rate have to be higher, because this liquidity premium is positive, has to be higher than the average of the short-term bonds in order for the investors to be willing to invest in the long-term bonds. So the question here basically is about how to come up with this liquidity premium, because here we are given a series of the short-term bonds interest rates. We are also provided with this long-term bond annual interest rate. If you look at this chart, this multi-year bond rate basically refers to that INT, that annual long-term interest rates. So how do we calculate this liquidity premium? Right, so that's the question here. And why don't I copy the numbers, open a new window. So 2%, this is a 1 year. So let me just write down the 1 year bond series. A series of 1 year bond. This is simply. And their interest rate 2%, 3%, 4%, 7%, and 9%. And this is a multi-year bond. So their annual interest rate, obviously multi-year, when the year is 1, that should be the same as the 1 year bond, right? That's exactly what's provided here. And the 2 year bonds, every year you expect to earn 5%. So that's 5% there. And the 3 year bonds, every year you can earn 7%. And for the 4 year bond, every year you expect to earn 8%. And finally, for the 5 year bonds, you can earn 9% for the every year. So this is the multi-year interest rate. So this is basically, going back to the lecture slides, this is basically this INT here. And you are also provided basically this IT plus 1, IT plus 2, and IT plus n minus 1. You're provided with these numbers. So these numbers basically are the 1 year series of interest rates, 2%, 3%, so on and so forth. And this INT here is basically 2%, 5%, 7%, 8%, 9%. So in order to calculate this liquidity premium, we first need to calculate the average of this future a series of 1 year interest rates. So for the 2 year, let me just calculate that. For the 2 year, obviously you can do the 1 year first. If we go back to the blocks, actually, yeah, that's the first one. So that's the 1 year. And 1 year, obviously, the average of the 1 year bond, that's simply 2% average. So 1 year, that's 2%. And then liquidity premium for 1 year, L10. That's, remember, this is the average. This first number I just calculated is the average of the 1 year bonds. That's basically, going back to the slides, that's basically this component here, the first component. Then the liquidity premium should be just the difference between this component, the first component. actually difference between the long-term interest rate. In this case, it's just a multi-year bond interest rate is 2%. It's the 2% minus this first component, right? That's what this LNT equals, minus that. So that's 0%. And then go on, 1 year, that's no brainer actually, because there's no discrepancy between the maturities. But 2 years, starting from 2 years, then what we should do on the first step is to calculate the average of the first two 1 year interest rates. That's basically this, the first term on the right hand side. And then this L20, that stands for the liquidity premium for the 2 year bonds. That's equal to the actual interest rate, which is remember this 5%, that's the 2 year multi-year bond interest rate, right? That's 5% minus, that's basically this INT here, minus this number 3% we just calculated, because that's the average of this first two interest rates. So that's 3%, and so on and so forth. 3-year bond, then first take the average of the first 3 interest rate for the 1-year bond, and then L30, that equals to the actual interest rate on the 3-year bond, 7%, minus this the average of this 1-year interest rates. And then 4-year bond, the first take the average of the first 4 interest rates for the 1-year bond, and then L40, that equals the actual interest rate, annual interest rate on the 4-year bond, 8%, minus this average of the 4 interest rates. And finally, 5-year bond. This equals to average of the for all 5 interest rates. And then L50, that equals the actual interest rate on the 5-year bonds minus the average of the 5 1-year interest rates. That's this. So now we can just copy these numbers. These are what we need: 0%, 3%, 4%, 4%, 4%. Copy these numbers into these blanks: 0%, 3%, 4%, 4%, and 4%. Check my answer. Oh, gosh, did I miss some information here? 3%, 5%, 7%, 8%, 9%. First 5 years, this is 0%. This is the average B1, C1, 2-year, and oh, this one is wrong. Yeah, this one is why this equals 3%? That's kind of interesting. So this is actually this should be 2%, because this is a C2 minus 3%. So that's why it's oh, I see. The question might be the, did I keep 2 decimal places? Let me just do that. So in this case, you can see the number here actually is 2.5%. Entry response is rounded to 2 decimal places. Yeah, I didn't look at. I actually made a mistake, which I often advise you against. So this is 2.5% rather than, nice work. All right.